All right, let's talk about a chemical you've probably come across even if you don't recognize the name, permethrin. You'll find it on everything from flea collars to camping gear, and it's even used in medicine. So what exactly is this stuff? And how does this, believe it or not, flower-powered chemical actually work? Let's dive in.
So to get us started, I've got a question for you. What on earth could a beautiful chrysanthemum flower possibly have in common with rugged, heavy-duty military gear? It sounds like a strange riddle, right? Well, the answer is actually the key to this entire story.
And that answer is permethrin. It's a synthetic, man-made insecticide. But here's the crazy part. Its design is directly copied from the natural pest-killing chemicals that are found inside chrysanthemum flowers. That's right. One of the most powerful chemicals protecting our crops and our soldiers got its start as a flower's secret weapon.
Okay, so how do we go from a pretty flower in a garden to a super insecticide used all over the world? It's a really cool origin story, so let's get into it. So here's the big difference between nature's version and the one we cooked up in a lab. Chrysanthemums make these natural insecticides called pyrethrins, and they work pretty well. But they have a major weakness. They break down super fast in sunlight. So scientists basically said, okay, let's make a synthetic copy that can stand up to the sun. The result was permethrin, which is way more stable and just lasts a whole lot longer.
And once it was created, man, things took off. Before 1973, it was all about those natural pyrethrins. But as soon as permethrin was synthesized that year, its power and stability made it an absolute game changer. It basically took over and became one of the most dominant insecticides on the entire planet almost overnight.
So we know it's tough, and we know it's long-lasting, but what does it actually do to an insect? How does it work? Let's break down its ultimate takedown method.
Okay, so permethrin is a neurotoxin, and its method is brutally effective. I want you to think of an insect's nerve cell like it has a light switch, this little thing called a sodium channel that flips signals on and off. What permethrin does is it gets in there and just jams that switch permanently in the on position. The nerve starts firing like crazy, uncontrollably, leading to a complete system overload, which for the insect means paralysis and, well, lights out.
So the big question is, why doesn't it do that to us or to our dogs? Well, it all comes down to something called selective toxicity. Basically, our bodies are just built differently. Our livers, specifically, are incredible at grabbing onto the permethrin, breaking it down, and getting it out of our system before it can cause any real trouble. An insect's little body and super sensitive nervous system, it just doesn't stand a chance.
So you have this chemical that's deadly to insects, but pretty safe for most mammals. As you can imagine, that has made it incredibly useful, and you'll find it in way more places than you'd probably guess.
I mean, just look at this list. It's used in agriculture to keep our food safe, in public health for things like mosquito nets, you'll find it in your ant and roach spray at home, and even in shampoos for treating head lice. And of course, it's a huge component in flea and tick products for dogs and for treating outdoor and military gear. It truly is the everywhere chemical.
And really, we can't overstate how important it is. When you think about the global fight against horrible diseases like malaria, Zika, or Lyme disease, well, permethrin-treated bed nets and clothing are absolutely frontline tools that save countless lives.
But, and this is a huge but, with this kind of power comes a massive responsibility. This is the point in our story where things take a really serious turn, because there is one critical life-or-death exception to permethrin's safety profile.
And the difference could not be more dramatic. While humans and dogs can break down permethrin just fine, for cats, it is an incredibly dangerous poison. They are missing a specific enzyme in their liver that's needed to process it. This means that even a tiny amount, what would be a safe dose for a small dog, can be catastrophic and very, very often fatal for a cat.
I want to pause here, because this is, without a doubt, the single most important thing you need to take away from this entire explainer. Let me be absolutely clear. You should never, ever use a flea or tick product meant for a dog on a cat if it contains permethrin. The results are just devastating. The symptoms are just awful. We're talking about severe tremors, seizures, drooling, a complete loss of balance and coordination. It is a terrifying medical emergency. Any cat showing these signs after a possible exposure needs to get to a vet immediately. No waiting.
Now, the danger isn't just limited to cats. Because permethrin is so powerful and used so widely, it creates these unseen ripple effects out in the environment that we have to be really, really careful about.
So remember that selective toxicity? Well, it has its limits. Permethrin is also highly toxic to incredibly important insects like bees, which is why farmers have to be careful to only spray when the bees aren't out foraging. And it's even worse for fish and aquatic life. Any runoff from a farm into a stream or a river can completely wreck that ecosystem. And here's the final twist in the story. The very thing that made permethrin so amazing, how well it works, has created a whole new problem for us. Pests aren't stupid. After decades of being exposed to this stuff, insects like mosquitoes and bedbugs are evolving. Many populations around the world have developed resistance, which means the chemical just doesn't work on them like it used to. We're now stuck in an evolutionary arms race.
All of this leaves us with a really important question, doesn't it? Permethrin is, without a doubt, an incredible tool. It protects our food, it protects our health, it protects people in high-risk jobs. But it also carries these huge risks for our pets, for pollinators, for entire ecosystems. A tool this powerful really demands an equally responsible user. The question is, are we?